budget for every possible prize combination. So basically, like, if you do something in Python with Postgres, you would be eligible for either of those prizes, right? So, the Python judges will review you, the Postgres judges would review you. And, if you won one of those, then it'd be great. So it'd be amazing if we, had prizes for every possible permutation. But basically, like, use whatever technologies that make sense to you. And as long as you use one of these things, you'll be eligible for at least one of the prizes, but you could potentially be eligible for multiple of these prizes, right? Even like, you can really use like, I don't know, you can use multiple retrievers even. So, we'll just consider all the things you're eligible for. And, but also to be nice, we're only going to give one prize per team because we want to be able to share the love. That's right. Yeah, I see. You're already optimizing what you're going to do. That's great. Go for it. So for the submission process, first you need to register for RagHack, and the way you're going to register for RagHack is actually by registering for any of the live streams. And we don't even check to see whether you've attended the streams. We don't have a way of knowing that, but just register for any of those live streams. Right? You can see them listed off our main repo here. So just any of these streams, whatever looks interesting to you, just registered for one of them. If you registered for today, then you're set. So you just have to register for any of them, and that will be considered registration for the hackathon. We don't have a separate registration for the hackathon, just register for any of these streams, including Spanish or Portuguese. And then you're going to submit your hack by filing an issue. So we're using the issue tracker as our submission. You can see actually somebody already submitted their hack. So they're really ahead of the game there. But if you create a new issue here, you'll see this project submission, and you'll put in your name, description, check any technologies you're using, give your project repository URL. That is a required field. Deployed endpoint URL is not required. So we don't want to have to force you to like keep something deployed, or even to have it deployed at all if it's costing money, right? So that's optional. So the things that are required are a repo URL and we'd also like a video. It can be a short video. You can use it make it with free software, QuickTime on your Mac or whatever you have. But it really helps to have a video that walks through it, just a screen share of how it works. And then team members, which is any team members you worked with on the project. So you do one submission per project. I did see there's a question about whether prizes can be sent out of the USA. And yes, prizes can be sent out of the USA. There is a few countries that we unfortunately can't send prizes to. I think that they are listed in here. So here you can see. So unfortunately, these countries we are not able to send prizes to due to payment laws. But there's a whole lot of other countries that we can send prizes to. So you can read more in the official rules there. But hopefully that includes all of you. All right. And yes, a team size can be 1, 2, 3, or 4. There was some confusion about that in the discussion thread, but we're trying to make it clear in the rules. But it can be 1 person, 2 people, 3 people, or 4 people. We're going to try and cap it at 4 this time, just because teams of 5 it's just a lot of people to have on a team. So we're going to say it's between 1 and 4 this time. All right. Okay, so there you go. So that is RagHack. Let's see if I covered all the questions. Can virtual teams participate in the hackathon and win prizes? Yes, every team is virtual in this hackathon. This is a virtual hackathon. So for sure, virtual teams are encouraged to participate. And a solo submission is it's just treated as a submission. So you're welcome to submit solo. You don't have to have team members. If you have any team members, just make sure you note them in your submission and that you don't have more than 4 team members. Is the prize a gift card or a money payment to a card? I don't think it's a gift card. I think it is money. I'll let maybe Josh can reply to that in the thread if he has the details about how that money is sent. All right, so I'll keep going with RAG 101. If you do have more questions, go ahead and post them in the chat, and hopefully we can get more answers to you. And if you ever have additional questions, go ahead and post them in our discussions forum here. We are watching the discussions and answering them here as well. Sweet. All right, so let's talk about RAG 101 for those of you who are new to RAG. So let's start off with just a brief overview of LLMs. Not everybody has had the chance to play around with LLMs yet, but basically an LLM, a large language model, is a model that is so large that it achieves general purpose language understanding and generation, which means we can use it for multiple tasks. We can use it for summarization. We can use it for sentiment analysis. We can use it for question answering. We can even use it for math sometimes, but it's not that great at math. You can see in the stats here. But we can use it for a surprising amount of tasks. We can use it for translation, right? So it's been trained on just so much data with so many training rounds that it's able to do many, many tasks. And so that's really exciting for all of us because we can use it. We can use it for things without having to train our own models. And there's many LLMs that you can use on Azure. We started off with Azure OpenAI. This is our classic, GPT 3.5, then GPT 4. These days, it's all about GPT 4.0 and GPT 4.0 Mini. There's also embedding models like Ada 002 and now the Text Embedding 3 series. So if you want to use those on Azure, you're going to use them either via Azure OpenAI or via GitHub Models. So if you haven't checked out GitHub Models yet, definitely recommend that you check it out and get on the wait list. There is a wait list and they're adding more people on every day. But the really cool thing about GitHub Models is that you basically get access to all these models that are hosted on Azure, but you can use them for free for a certain amount of usage each day, right? So you get like 200 requests a day or something, right? So you're not going to use them, for your production app, but you can definitely use them for doing like experimentation and developing and stuff like that. And you can easily swap between different models here. So here you can see they have the OpenAI series, and they also have, the Phi 3 series, and then, things from Meta, Cohere, Jamba, Mistral. So if you have not joined the waitlist for GitHub Models yet, do join the waitlist. And if you have access to GitHub Models already, that is great because you could take advantage of those to be able to use models for free during this hackathon. And it's really cool because you can basically open up a GitHub code space with any of these, and you can just start using them immediately without having to do any sort of Azure sign up at all. And you can see the instructions here for GitHub Models. You can get instructions in Python, JavaScript with different SDKs. So it's a really, really nice experience. So definitely sign up for that if you haven't yet. And then there are the other models, and we saw some of them in GitHub Marketplace, right? So we've got the Phi 3, we've got the Mistral models, Cohere, and Meta. So those you can get from Azure AI Model Catalog. And here's a link about Azure AI Model Catalog. So you can get them from there or from GitHub Marketplace, right? So GitHub Marketplace is only for playing around. Azure AI Model Catalog is where you're going to get them if you're going to be using them for production. So this, you'll sign up for an Azure account and then deploy them from there. And quite a lot of models that you can use from there. So you could use any of these LLMs when building RAG applications. Now, another way you can use LLMs is to run them locally on your computer. And this can also be a tool when you're developing and hacking. And it's really helpful because it can be a way to do development with LLMs for free. So there's this tool, Ollama.com, and it puts a little Ollama in your taskbar here. And it lets you run local models, small models locally. And it's actually doesn't necessarily require a GPU. It has a trick where it can run them efficiently with just a CPU, which is really nice for me. Like I don't have a very powerful computer. I have a Mac M1, but I'm able to, run these things. So I can be like, let's see, DT, Ollama, run, what is it, Llama 3.1. So you need to like, you go to Ollama and you look up like the name of the model that you want to run. You're like, okay, Ollama. And then you check out their models. All right, and we see 3.1. Yeah, so then I said, oh, Llama run Llama 3.1. Okay, so then I can say, oh, hi, what's up? I never know what to say. And it'll send a request to the LLM and answer it like, okay, we'll ask it, what does RAG stand for? So this is running entirely locally on my machine and it's able to respond pretty quickly. This is only a 7 billion parameter model, as I can't run the the larger models on my machine because I was saying I don't have that much power on my machine, but you can do quite a bit with just this Llama 3.1 model. And I have got RAG repos that are running entirely on Llama 3.1. So this is another option when using LLMs. So I saw some questions about, oh, can you use multi-modal from Hugging Face? So generally for this hackathon, whatever you hack should should involve RAG in some way, because this is RAG hack, and then should involve Azure in some way. So you might decide not to use an Azure LLM. You might decide to use a different LLM. And I think that's actually okay. I guess I'll talk about it with the team. I think it should just be it's RAG and it involves Azure in some way, right? So maybe you're using Azure OpenAI, maybe you're using Azure Postgres, right? But we basically want to see different ways that people build RAG on Azure. And so sometimes people do solutions that are 100% Azure, which is really cool. It's great for us. But sometimes people will also mix and match Azure technologies with non-Azure technologies. And that's also, we're talking about the cloud here. And in the cloud, we have portability. So I think that's also a really great way to build a RAG. And we want to be able to support people, mixing and matching Azure technologies with non-Azure technologies, right? Because as developers, you want to pick the best tool for the job. So yeah, that's my response for that. Oh, I said, can you share the trick that allows efficient use of the GPU using Ollama? You can read about that on Ollama. I believe the trick is called GIGUF or something, maybe for giga format, a binary format. I think that's one of the tricks at least. But I'm sure you can find more on Ollama, probably on their blog. Probably has more information about that, or maybe in their docs. Great question, though. All right. So let's see how we can use LLMs from Azure OpenAI. I'm actually going to show it just via a HTTP request, right? So we expose all of our LLMs, our hosted LLMs, using HTTP endpoints, right? So let me go ahead and open it up. So I have this .http file here. I'm in VS Code. I'm using the VS Code REST client, which is really cool extension for sending off HTTP requests. If you're not using it yet, I just discovered it. It's very cool. You can like put all your HTTP requests in files and then just send them off. So let's see. So here I am making a post to my OpenAI endpoint, and I've got some things in a .m file so I can change them. So I'm making it to my OpenAI endpoint on Azure, and I'm making it to a particular deployment. So when you use OpenAI models on Azure, you will make a deployment for each model you want to use, right? So if you want to use a GPT-4o, you'll make a deployment for it. And for that deployment, you can configure stuff like how much tokens per minute capacity you need and stuff like that. And then I'm making a request to the chat completions endpoint. So I'm saying I want to do a chat completion to this model deployment for this service. And then I'm passing along my my token. And then it's JSON. Okay. And then here's the JSON that I'm sending along. So in this JSON, I've got the system message, and the system message says you're an AI assistant that answers questions with short, clear answers. So here I'm giving the general vibe. And then I'm sending the user request, which is how fast is the Prius 5? And then I've got parameters. So I've got max tokens, which is the maximum amount of tokens I want it to send back. So here I'm saying 800. And this is a nice tool for keeping answers shorter, and also just for making sure you don't go over a budget of tokens. Then I've got the temperature, which is generally how creative it's when it's deciding what word to pick, like how much variability it allows itself. We've got some, actually, I've never even used these ones, frequency penalty and presence penalty. I'll have to look those up. Top P is kind of similar to temperature, and stop I also don't really use. So most of these I don't use. Usually I am just using max tokens and temperature. So I'll remove those ones that I don't usually use. This extension is called the VS Code REST client extension. So you just look for REST client. Here we go, from Huchao Mao, REST client. All right, so then what I'm going to do, I'm going to try sending the request and seeing if my token is still valid. Let's see, 200. Okay. All right, great. So it worked. And, we see all the headers come back here. And what you'll see in the response is actually what you first see is what comes back specifically from Azure OpenAI, which is content filter results. So whenever you use models on Azure OpenAI, you do your prompts and responses get sent through the Azure OpenAI content safety, right? So here we can see that it didn't find any violations of these filters, so that's good. And then we get the actual response, right? So it says, oh, Toyota Prius 5 has a top speed of around 103, can accelerate from 0 to 60 in approximately 10.4 seconds. So it gave me a response, and that this response is just based off of information that it saw from its training data. So presumably in its training data, it very frequently saw that, Prius had 103 and 10.4 acceleration. And then we see additional prompt filter results. So this is whether our prompt violated anything. And over here was whether the response violated everything. So you'll see those always when you use Azure OpenAI. We can also see how many tokens we spent. So we spent 31 tokens in the response, 31 tokens in the prompt, and a total of 62 tokens. So this was a pretty small, pretty cheap request here. Yeah, I see a question. What if you don't have access to OpenAI models on Azure? We used to require people to fill out a form for access to Azure OpenAI. I believe we no longer require people to fill out that form. So I think if you have an Azure account, I think you should be able to access Azure OpenAI. But if you don't, you could use openai.com. And most of our repos will have support for switching in openai.com. And that would just look like a different request. It'd be like openai.com, and you pass in your key instead of a token. Or you could use GitHub models if you get access to that, and you could use that during development. Or you could use Ollama. So you can use those 4 options, and there might be even more options that people want to suggest in the chat. And you can usually use them with the API packages, of your choice, right? So this is an HTTP request. Usually, of course, I'm writing in Python. I'm trying to do not too much Python in this since we have a Python one coming up later. But I will show you that generally, with any SDK, you should be able to point it at Azure, at Ollama, at GitHub, or at openai.com. So I try to write all my demos in such a way that you can easily swap out who's hosting them. And say maybe other folks can even mention other options for LLMs that you can point to that they've had good success with. All right, so that was a basic chat completion request. So let's keep going here. And you can get all these demos are from Python OpenAI demos, which we can put in the chat. Oh, we already did put in the chat. Okay, so you can go ahead and grab these demos from that repo if you want to see them in more detail. So the thing is that these chat completion requests are limited, right? Because they have outdated public knowledge. Their training data is up to a certain point, and they have no internal knowledge. They haven't seen anything that wasn't in their training data, right? So we have generally 2 options for how we can bring in domain knowledge. The first option is fine tuning, and that's where a model will actually learn new skills permanently. So it's actually coming up with like thousands of examples and then training the model, like just training like the final layer of weights to change those weights so that the responses will will be correct for the training data that we've given it, right? So that takes time because you have to do the fine tuning step, and that can take like, a day or more depending on how many examples you have. And it costs money both for doing that fine tuning and for running a fine tuned model. So fine tuning certainly is an option, but it's not the first option that most people go to because of the high cost in terms of money and time. We are going to have a session about fine tuning for RAG specifically. So if you are interested in fine tuning, I do recommend attending the session from Cedric. He's going to talk about Raft, which is a way of doing fine tuning specifically for RAG. It's a very cool technique. It comes out of the Berkeley Research Lab, which is just down the street from me. And it's very cool. So he will be talking about that. But most of the times people do just straight RAG, and that's what we're focusing on here. It's a little more approachable. It doesn't require such upfront cost and time. So let's dig into RAG. Okay. So RAG stands for Retrieval Augmented Generation. So imagine we have this question: how fast is the Prius 5? We use that question to search some sort of search engine, database, document store, something that has the results for that information, right? So in this case, we get back a table of Prius with their year and MSRP and acceleration, and then we send both the original user question and that table to the LLM and say, hey LLM, you need to answer based off these search results, and stick to the search results, and we'll get an answer that is according to those search results. So let's go ahead and check that out with our HTTP again. Okay. So here we have the system message, and this time the system message is a lot longer because I'm telling it what it's answering questions about. So you answer questions about cars based off a hybrid car data set. You must use the data set to answer the questions. You should not provide any information that's not in the provided sources. Sources are provided as a markdown table. Refer to the row where you found your answer inside square brackets. So I'm giving it a lot of information here. I'm describing how I'm going to provide the sources, the format of the sources. I'm telling it that it has to stick to the sources and it shouldn't go off script. And I'm telling it how to make a citation, right? So these are the general ingredients of the system message for a RAG application, is that you're telling it, what sort of questions it's answering, what the data sources are going to look like, how it's going to make citations, and what it should do if it can't find the answer. And then we have the user question, which has the actual question from the user, and then it has the sources in some sort of format. So in this case, the sources were a markdown table. You might also send along like JSON. You might just send along a bunch of paragraphs. It just depends on the kind of sources you're working with, right? So these came from an earlier step of actually, searching some data store. And so then we have it, right? So this is basically a RAG request, like this kind of simplest RAG request here. All right, so we're going to send a request. All right, and we get back a 200 okay. So we're going to go back and look back and see here. It says the acceleration time for the Prius 5 is 9.51 seconds. And then for its citation this time, it decided to just say row 6. So I'm going to assume that came from row 6. Let's see, Prius. Yeah, it looks like that is row 6. So it decided to cite it as row 6. We could tell it more precisely, like give an example of how we wanted to cite the rows. But there we go. So it came up with an answer based off the table. Now, the interesting thing is that this answer is different from the answer we got from the chat completion request, right? And that's because this time it's going based off the sources, not on what its weights. Now, I Googled it or Binged it, whatever, to try and figure out which one was correct. And I actually got the other answer more often, but it could just be that this data, isn't quite correct. I'm not sure where the data came from. So generally the answer is going to be as good as what you send it, right? If you send it correct sources, then the LLM will do an accurate job answering. If you send it incorrect sources, it's going to answer incorrectly. So with RAG, so much is about the retrieval, right? Like we think about this as being an LLM thing, but really, if you get the retrieval correct and you're able to send it good information, LLMs generally can do a really good job answering. right? So that's why we have so much of a focus in our streams about different retrieval mechanisms, how to do retrieval best, and all of that stuff. Because really, in my experience and all the evaluations I've run, it all comes down to retrieval. And if we get that retrieval good, then we'll generally have a good answer. So Derek asks, can you provide an example of where to access the document source table? Yeah, so this one was based off just a CSV, is literally coming from this CSV here. And, I was just doing a really, here you can see the Python for it, where I was just searching that CSV. That is not a good RAG. That's not a production RAG. So the examples will be showing, we'll show you how to do RAG on Azure AI Search. We'll show you how to do RAG on Postgres. I'll show you a quick RAG on AI Search, but we'll show this more in the in the session on AI Search. But just to get a feel of what it looks like, this is in Python with AI Search, right? So I get a user question, I get a vector embedding for it. I then search a search index for matching documents, and that's that search request here. I get back the documents and I join them together with new lines. That gets us a bunch of sources that look like this. So in this case, our sources are file names with page numbers, and then they have chunks of paragraphs from those sources, right? And we send along like 3 of those, and then I send that to the LLM. So that's an example with AI Search, but generally it's going to look similar. Whatever retriever or framework you're using, is that first you're going to retrieve it, get the user question, do any sort of cleanup or embedding of that user question that you need to do. If you're going to do a vector search, send that to your search engine, vector store, whatever, get back the results, concatenate the results in some LLM appropriate format, and then send them both to the LLM with a good prompt that tells it to stay on track and tells it how to do the citations. All right. So yeah, good question. And we're really going to go into detail on all those in the follow-up streams, since there's so many different retrievers that we have. But once we do, start using a good retriever and doing RAG, then we've got up-to-date public knowledge, and we've got access to internal knowledge, and we've got citations so that users can click through and see where did you get that answer from and decide for themselves if they trust the answer. Now, you've probably seen lots of RAG in the wild, right? So the one I use the most is GitHub Copilot, right? And when I ask it questions like about my workspace, and it'll look through my whole workspace, and it can answer questions based off the workspace. And you see it says, "Oh, use 7 references," and answers the question here. There's also Bing Copilot. When you're actually searching, you can ask questions on Bing, and it'll basically do the search for you, and then send all those search results to the LLM, and then answer based off those results. And then there's also Teams Copilot, which maybe some of you have tried, which is basically a RAG on your chats. And this time the citations are to your chats. So what you see in similar here is that all these RAGs use citations, right? And they all have different sources, like different data sources, different data types, right? In this case, for Teams Copilot, the sources are chats, conversations. For Bing Copilot, the sources are actually web pages. And then for GitHub Copilot, the sources are, source code files. So they all have different data sources, and they all probably use a different retriever, right? Like I think GitHub Copilot might use SQLite with a local TIFID diff, TF-IDF locally. And I don't know about these two, how they're implemented behind the scenes. But the important thing is, these are RAGs. They show you kind of the breadth of what you can do with a RAG. So let's dig a little more into some types of RAG here. So we're going to show some different flows and some different data sources to get you thinking. All right, so we're going to start with a simple RAG, right? In this case, we're going to show a RAG on a products database, outdoor shoes company or outdoor gear company. So we're going to ask, what's the best shoe for hiking? And use that to search a database and get back rows from the database. And then send both the user question and those rows to the LLM, and then get back a response. So I actually have this implemented in this Postgres demo here. So I'll show it here. All right, so I'll ask best shoe for hiking. So what this is doing is, sent off that request and got an answer, streamed it in and showed the references. And I can click on this light bulb here and see the thought process. So we always like to have this thought process in our RAG applications just to help us understand what's going on. So here is the query, right? It did best shoe for hiking, and it's going to do both a vector search and a full text search. And these are the results it gets back from the Postgres database. This is an Azure Postgres flexible server database. And so you can see, these are basically the rows of their columns. These are the columns of that database table. So we get those all back. And then we send them to the LLM. So we say, hey, LLM, here's how you do it. This is how you do citations. Here's the user's question, best shoe for hiking. And here are the sources. And, we just concatenate them with new lines here. So this is what I call a simple RAG flow with a database table as the data source. And this is a great kind of flow when you are trying to do RAG on data that already exists, right? Like, for example, this is a products website. So you can imagine having a chat, on a e-commerce store that is, for users to ask questions about those products. But most of the times we use an advanced flow. So let me talk through advanced flow. So with an advanced flow, we start off with a question, right? And I say, oh, what's a good shoe for a mountain trail? And you can see that this question actually has a spelling error in it with trail. And I send this question to an LLM as the first step. So this is what we call the query rewriting step or query cleanup step. So I say, hey, LLM, please clean up this query for me. So it cleans up the query and then does the search. And then the rest of the RAG flow is the same. And this is what I pretty much always have in production. RAG is this query rewriting step. It's really, really helpful and it's really powerful. So let's take a look at that. So what did we ask? We said, what's a good shoe for a mountain trail? All right, I have a bunch of typos in that one. No problems. Okay. All right, all streaming in there, still talking. Okay. All right. So then we look at this and we can see that the first step is a LLM call. So it says, hey, here's the query. Please translate this into a good query. So here's the question. We give some few shot examples. And then it suggests mountain trail shoe. So this is really nice. It took this user question, what's a good shoe for a mountain trail, and turn it into the user query mountain trail shoe. And that's a perfect search query for our Postgres database, right? So this is really nice here. And so then we get back results. And then I could say like, oh, any for climbing. All right, so let's see what happens when I do this one. Okay, and it says for climbing, I recommend these climbing shoes. So notice I didn't say shoes in this request here, but it knew I wanted shoes. And that was probably because of the LLM rewriting steps. So let's take a look. Yeah, so what you can see is that this time it turned any for climbing into climbing shoes. So that's another reason that we really want that query rewriting step, because for conversations, users will ask questions where they'll like imply something from earlier without saying it, right? So here I'm implying shoes, but I never said it. So we really want to, clean that up and say, hey, what we should be searching for is climbing shoes, right? And that's a perfect search for, for the LLM. So that's really cool. I see a question about citing the sources. Yeah, so you should definitely mention how you want the sources cited and, potentially give examples, right? It always helps to give examples, right? So this one says, each product has an ID in brackets followed by colon. The product details always include the product ID for each product you use. Use square brackets to reference the source, for example, 52. Don't combine citations, list each product separately, for example, 2751. So we get really, really precise with this. And it definitely helps to be really specific when you're telling it how to do citations. And that's actually one of the things I find the hardest was doing RAG with some of the some of the open models, like lower parameter models, is that they often can answer the question correctly, but are not as good about providing the citations in a good format. Now, luckily, I have had success with Llama 3.1, and this repo I'm showing here is fully compatible with Llama 3.1, the locally run version, the 8 billion parameters. So Llama 3.1 seems pretty good. I haven't had success with any of the other small language models with getting citations correct. So this is something where you do need a powerful model to be good at following directions, right? The higher parameter models tend to be better at following directions, like how to make citations. And here you can see our prompt for query rewriting, right? Here's the history of the conversation, generate a search query based off the conversation, a new question. Don't return anything besides the query. So this is all open source, so you can go ahead. So if you're interested in that one, you can go and grab the code from the repo here, aka.ms/rag-postgres, and you can dig into the code and see how it's done. This is a great one to fork because this is also one that's fully Ollama compatible as well. So if you are thinking about doing a RAG on a database, the database table rows, this is a nice example. Good question. How many examples to include in the prompt so that it can generate citation correctly and consistently? I actually do not provide examples for that final prompt currently. If you are having problems where it's not doing it consistently, that's when you start using examples. The only part where I have examples here is actually on the query writing step because I was having a really hard time getting that working with Llama 3.1. But I did get it working once I provided examples. And now this query writing step is using function calling. So you can actually see my examples are providing examples of function calls. So we haven't talked about that yet, but basically function calling is a way of getting structured output from your LLMs. And I do tend to use it when I'm doing query writing because it gives me more options for getting structured responses back. So all of my examples here are actually function call examples. And I did find that I needed these to get this working with the the smaller local language models. I didn't try doing few shots for this prompt yet, but it's always an option, right? So you just have to keep in mind like kind of your toolbox of options, right? You can do few shot examples, you can do system prompt engineering, you can do function calling, right? You can change the temperature, right? We always have temperature is something we can tweak with and see how that improves responses. So there's many different things that you can change when you are, experimenting with answer quality and trying to improve it. These are great questions. All right. Okay. So let's keep going. So we talked about the query writing. Okay. And yeah, so here you can see that we are doing query writing with function calling. And this is because I also wanted the LLM to suggest SQL filters potentially. So I'll show the example where we need this, right? So if the user asks, hey, do you have any climbing gear cheaper than $30? It says, yes, we do have climbing gear below $30, and it gave the responses. So I wanted my query writing step to suggest both a search query and a SQL filter for the price column because I want to actually filter down those rows according to price before I even search for whatever they want to find. So what you can see here is that during this query writing step, it did actually suggest that I do price less than 30. So this is another reason why I use function calling for query writing because it gives me the option to have it make maybe like fancier suggestions here, right? So it suggests both climbing gear and it says, hey, I think you should use a filter of price less than 30. And so that way I apply the filter first, then search for climbing gear. And so that way all of the results are less than 30. So that way this really improves my answer quality because generally LLMs aren't very good at reasoning about numbers and getting exact numbers right. So when it comes to numbers, I really want to use a database filter to do that first. and then get back results that are all eligible as being less than 30. And here are the few. So this is the one why I use few shot examples. So you can see here few shot examples that are actually with these price filters here. And that really helped out. So when I say few shot, I just mean examples. Few shot is like the fancy way that we just say examples. So we're just giving, pretending like these things actually happened in the conversation to show it how we expect it to behave. And there's been a lot of cool research into, optimal few shot examples, right? So this was actually based off of, I think, LangChain. Can I find their blog about it? There we go. They had a great blog post here, few shot prompting to improve tool calling performance. So that was what I referenced when I was developing this. And they did a bunch of examples where they did like no examples, where they used like examples based off of what they thought the query was asking for. So they had like a bunch that they picked from. And that did pretty well. But yeah, so really, really interesting things there. I'll share it so that you all can read that blog post. Okay. All right. So these are great questions. Let's keep going. And now let's talk about RAG on documents, because this is what a lot of people want to do when they want to do RAG. All right. So here we have a user that comes to like a company RAG chat and they say, hey, do my company perks cover underwater activities? So we take that question, we use it to search a database, and we get back responses. And so these responses are actually chunks from documents. And then we take both the user question and the document chunks, send that to the LLM, and get back a response. So this is implemented in aka.ms/RAG chat. This is our most popular RAG sample, and it's one that we'll be showing quite a bit during these sessions. So we'll be digging into it in many of our sessions, and I can show you the demo for that. So actually I've already run it. All right, so here, what does a product manager do? Blah, 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 blah. Here's the citation. The citation's to a PDF. And when I look at it, I can see that I do use the query writing step. And this one actually has few shot examples as well. And that comes up with this. And in this case, it didn't transform it, but that's fine, because that's a good search for this one. And then I search Azure AI search. So that's where I've indexed all these document chunks. And you can see I get back a bunch of document chunks, and each chunk has an associated page and page number. And they also each have a vector embedding, and they even have an image embedding. I did see a question about whether, you can do RAG on images. You can. It's a lot trickier. We are going to I'll have a session about it next week. And I have a blog post about it too. I'll try to publish that tomorrow, I guess, so that y'all can see how we did it. But it is possible. And we'll talk more about that in the RAG with Vision segment. And then we send those search results to the LLM. Right. So the big difference here is that this time we're dealing with chunks of documents, right? Which means we do need what we call a data ingestion phase, which is where we take the documents, we extract the text from them, we chunk them up into appropriate sized chunks, and store those in our index. So what we've seen is RAG on database rows and RAG on documents, like unstructured data. So if you're doing RAG on database rows, you need some way to search your columns, right? And you want it to be like a pretty darn good search, because users, they're asking questions. And so you need a way that you can search for user questions, which can be, filled with like weird spelling and punctuation. So you should use a query writing step, but still have a really good search step too. So usually that means you also want to be using vector search in combination with full text search. So on Azure, your options here are Postgres, which is what I showed. You could also do Azure SQL, which does have an upcoming vector search feature. So come to the stream to learn about that and get private access to it. Cosmos MongoDB with vector, or even Cosmos NoSQL with vector support, right? So you've got a bunch of options for doing RAG on database rows. And then for RAG on documents, you do also need a data ingestion process for ingesting all those documents. I generally recommend Azure AI Search plus Azure Document Intelligence for this flow. I'll talk a bunch about that with Farzad in our Thursday session on AI search. So if you are interested on RAG on documents with AI search, or even with anything really, come to that Thursday session, and we're going to dig deeper into how we actually do the data ingestion and the search and all that stuff. We do have an example of advanced RAG that we want to encourage you all to use and give feedback, which is a GitHub agent. So I don't know if any of you have used GitHub Copilot agents, but we have this at Azure agent that we're trying to make it be helpful for those of you who are developing on Azure. And Chris Harris, he's the PM working on charge of it, and he would love to get all of your feedback on it. There's instructions here for joining the preview of it, aka.ms/GitHub Copilot for Azure. So if you are developing in VS Code and you use GitHub Copilot, sign up for this agent and ask it questions. And if it does a good job, thumbs up. And if it does a bad job, thumbs down. And that will help us improve the agent. But this agent is itself also an example of RAG. And it's actually a RAG that uses function calling in order to figure out, how it should answer a particular question, right? So it looks at the user's question, uses a function calling step in order to figure out what it should do next, and then, will do the next step in the chain. All right, so for building a RAG app, as you've seen, we need a retriever and we need an LLM. Those are the two main things we need, right? So a retriever, we've got lots of options on Azure. There's of course also non-Azure options, or even stuff that, like Quadrant, that can run on Azure as well. And we need the LLM. So we've talked about lots of different LLMs that we can use on Azure and also locally. Now, optionally, you might want an orchestrator, right? So an orchestrator is like a library, a package that makes it easier to organize calls to the retriever and the LLM. I don't personally use orchestrators, so I can't like tell you which one to use or not use. I mean, I've used them like just briefly, but all of my samples just use the OpenAI SDK and just that, no orchestrator. But many people love orchestrators. So if you like working at that kind of level of abstraction and you like all the where you can look through the docs and figure out how to do a particular task, then check out LangChain, Llama Index, Semantic Kernel, PromptFlow. Those are all popular orchestrators that you might want to use when developing a RAG application, right? The general thing you have to remember is that whenever you use a library, you're going to have to learn how that library works, and you may run into limitations of that library. And sometimes it's worth it. Like a lot of times it is worth it to run into limitations of the library because of how much the library does for you, right? So that's the same thing when it comes to orchestrators. If the orchestrator does a lot for you and makes it way easier for you to develop your RAG application, then awesome. Use an orchestrator. If you find yourself running into its limitations, then you may need to move off the orchestrator and use something more lower level. That's the debate you have to make for yourself. On Azure, we do also have like lower code ways of building RAG. We're not really focusing on that this hackathon. This is a hackathon, but it's worth pointing out if any of you are watching who are looking for lower code or no code ways of making RAG. We'll be focusing on the high code. But for no code, we've got Copilot Studio, so you can check that out. For kind of middle code or low code, there's Azure OpenAI Studio on your data, which is a wizard that you can use to build a RAG application, build a search index, build a database index, and then you can actually kind of fork the code and work off it. So it's kind of no code, but can also become code if you want it to be. And then what we're going to be really focusing is all the high code solutions. So here, we'll be focusing on, we'll have all these different sessions to dig into different ways of building RAG apps and different repos, right? So, we'll look at this Python one in the Python session will be later today. So you could join that session if you're interested in Python. I know a lot of people are developing in Python. Woo woo! That'll be my session. So hopefully I'll see you all come back for that one. We have a .NET solution, and there's going to be a session on that, which is also today and coming up very soon. And that one uses Azure AI Search with Semantic Kernel. There's going to be a JavaScript session tomorrow, and they're really going to be focusing on their Cosmos DB for NoSQL plus LangChain JS solution using Azure Functions. So that'll be tomorrow from our European advocates, bright and early for me. Java, we've got a bunch of different Java sessions. So there's one on Java and semantic kernel. That's the one shown here. There's also going to be a session tomorrow about Java with LangChain 4j, and there's also going to be a session next week on Java with Spring AI. So if you're in Java, you've got 3 different sessions that you could attend based off which framework you want to try. And then there's Azure AI Studio, which is Azure AI Studio is an actual studio UI where you can use to build flows and deploy flows. So we are having a session on that today and digging into that. So come to that if you want to check out AI Studio. And then we have all of our next steps here. So you're going to register for the hackathon by registering for any of the streams. And then start hacking by trying code samples. So if you're looking for code samples, you can go to the repo and scroll down and look for RAG code samples. And so these are the main ones that are going to be featured in sessions. There'll be a few more as well, but I tried to identify the main ones for each like retrieval and language. And, hopefully I got most of them, but I'll keep updating if I need to. I talk about the costs here because we don't want to have you all like spending a lot of money in order to hack. So there are 2 of them can be run locally for free with Ollama. So that's this one and also the Postgres one that I showed. So that those 2 can be good ones to start off with. And then for the other ones, I did link to the cost estimates for deploying. For the one on AI search, we also have a specific guide for how to deploy it to free tiers. So you can follow that in order to deploy to free tiers, and that will be much more economical, right? Yeah, so definitely check out this list of code samples. I saw the question about Vision. If you're interested in Vision, that is implemented in this Azure Search OpenAI demo repo. It is a optional feature that is documented here about how to do GPT Vision. So if you are interested in Vision, that would be, one way to get started with it. That's for RAG. Yeah. So I think this is the only RAG on Vision repo that I know of. I'll look and see if there's other ones too, but that's the one I'll be talking through for my session. Yeah, and then okay, I see a good question. How can we enhance the result to question using RAG? Like ask the model to display a math transform as an answer to the chat. So for that question, I'm going to always be like just recommending streams, right? But we're going to be talking about on September 10th, OpenAI Code Interpreter for Python. So this is the ability to have the LLM generate code and then execute that code inside a sandbox Python environment. That means you could ask the LLM like, hey, can you write matplotlib code? And it could generate a chart using matplotlib, right? You could also ask the LLM to write a bunch of pandas code to do data analysis, right? So that is the approach that I've been recommending to people who, basically want to be able to kind of have the LLM execute arbitrary code. I think it's the easiest way to have it come up with a chart, because there's things LLMs are very good at pandas and matplotlib. So I think that's the best way to have it generate a chart. You could also use function calling, but I would definitely recommend that session for that. All right. I saw that. Okay, I guess the GitHub Copilot for Azure repo is 404ing. So I will ask Chris Harris about that after the session and get an updated link. Probably put it in the discussions. I'll just start a new discussion. The question is, do you recommend an orchestrator for a production grade app, and what are the benefits? So I think generally, when it comes to orchestrators, the benefits for me is actually that they've already figured out how to do particular RAG flows, right? Like I showed you like a simple RAG flow and advanced RAG flow. They've got so many different flows that they've, implemented, right? So if you go to Llama Index, right, they'll show you how to do just a lot of different types of flows and agents and stuff like that, right? Or LangChain, obviously, similar, right? So I think the big advantage is they've figured out how to do particular flows. Like for our code interpreter session, it is actually going to be using LangChain because they already have a nice code interpreter agent. So I think it's like if you find that they're already, doing a particular kind of RAG that is complex and requires like a chain of calls or something, and that you feel more confident using their thing, then that's a nice reason for using Orchestrator. What I like to do is I look at the code that they use behind the scenes. I, go into their GitHub, and then I try and see like, okay, like, how complicated is that code? Do I just want to write it myself, or do I want to use them? So I think, when it comes to using orchestrators, I think it's probably something you want to experiment a bit with, get a feel for them, see if you like them, see if you don't, right? There's really, people have different opinions on it. But do remember, you can always like look at the code and see how something is done. And that to me is really valuable, because I think of LangChain and Llama Index as being kind of like documentation of the kinds of things we can do with LLMs, even if we don't use Llama Index or LangChain. Like they have documented, like, this is a particular kind of way we can work with an LLM, and here's how we do it. All right. Oh, and then also, I saw there's a question about like getting access to experts and stuff like that. We're also going to be having some office hours, and we're going to add at least one more office hours here, and we could, we can ask about more depending on what you all want. But I'll have like office hours tomorrow. Bruno from .NET team will have an office hours on Friday. We're going to add an AI Studio office hours, and we can keep adding more office hours, as people need. Just let us know in the streams or in the discussion forum, how we can support you in your hacks, right? So these office hours can help because you can actually share your screen during them. They'll be in our Discord. So if you're having some issue with setup, we can hopefully help you through the setup. Okay. All right. So we are now at time. So I will go ahead and call it and the stream. But if you do have additional questions or if you want to see the slides, so for each of our sessions, we have a link to the resources. Like for this one, here's the resources thread, and you can see these are my slides. You can get the PPT, you can get the PDF. We'll link the recording here. You're welcome to ask follow-up questions in this thread. You're also welcome to ask follow-up questions and discussions. Josh and I will just be watching every discussion. So just, post your questions somewhere in the discussion, and we will see it. And we'll try to, we'll either answer it in discussions or in a stream if you're in the stream. All right. So yeah, and there's so many questions. These are so fun. I could just talk RAG all day. But I will be talking RAG later today. So come to our streams coming up. We'll be talking about .NET. We'll be talking about Python today. We'll talk about AI Studio. So we can keep answering lots of questions during those. So please join us. Love seeing all of you having such great conversation in the chat. All right, we'll see you later then. Bye, everyone.
Thank you, everyone, for joining. Thank you so much to Pamela for a great kickoff. To learn more about the series, you can follow the link at the bottom of the screen or in the chat. We are always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in